Hello and welcome to another Mr. Marriott Maths video. This time we're attempting question 3 from Leeds Maths School Decision 1 Assessment 7. So we're told that a list of 11 numbers is to be sorted into descending order. After one pass, the quicksort algorithm produces the following list. And we're asked to state with reason which number was used as a pivot for the first pass. So, after the first pass, we'd really hope that to the left of our pivot are entirely numbers that are larger than our pivot, and to the right of our pivot are entirely numbers that are less than our pivot. So we're going to go along the list and see which of these numbers satisfy that condition. So I'll pick 25 for example. To the left of 25 are the numbers 33, 14 and 17. These are a mixture of numbers that are greater than 25 and less than 25, so don't meet that requirement. 9 might look like it meets that requirement. All of the numbers to the left of it are greater than it, but to the right of it, we have a number that's greater than it and a number that's smaller than it. So 9 also doesn't meet the requirement. And if we go from left to right and see which one does, it's going to be the number 13. So looking at the mark team and seeing what it says, the number 13 was used as a pivot in the first pass as all numbers are greater than 13 or all numbers greater than 13 are on the left, and all numbers less than 13 are on the right. And that explanation gets you an independent accuracy mark. So I'm just going to select that and move it off to one side. And this is going to be an independent accuracy mark, B1. Moving on, part B asks us to start at the left-hand end of the above list, obtain a fully sorted list using a bubble sort. We're told that we only need to write down a list that results at the end of each pass. So 13 is a fixed pivot. Now we're going to select the numbers in the middle. Sorry, not a quick sort, it wants a bubble sort now. We did a quick sort to begin with, and now we're doing a bubble sort on this list. So we're going to go from left to right and bubble numbers, swapping numbers if they need to swap. Do 17 and 33 need to swap? Yes, they're the wrong way around. So we're going to get 33, and 17 is going to keep moving right until it no longer needs to swap, and it no longer needs to swap because 14 is now less than it. We're going to do the same thing with 14. 14 needs to move to the right until it reaches here, and it gets stopped by 13, which means that 25 moves to the left, 23 moves to the left, 28 moves to the left, and 21 moves to the left. We're going to carry on with 13. 13 is in the correct position because it's stopped by 9, and 9 is also in the correct position. 6 does need to change with 10, so we're going to swap 10 and 6 around. And now 6 is in the final position. So we're going to do this again. Does 33 and 17 need to swap? No, they don't. Does 17 need to swap with 25? Yes, it does. It's going to keep swapping until it reaches this position here, and then it's stopped by 14. So all of the rest of these numbers will move to the left one place. "14 does not need to swap with 13. 13 does not need to swap with 9, but 9 and 10 do need to swap around. Now 9 is in its final position. We're going to carry on doing this. 33, 25 are in the correct position, but 23 and 28 need to swap around. And 23 is greater than 21, so it stays to the left. 21 is greater than 17, 17 is greater than 14, and so on. There are no more swaps in this pass. And now 10 is in the final position. We're going to carry on. 33 doesn't change. 28 and 25 are going to change around though. And if we carry on this pass, we're going to see that there's no more changes in this pass. But there was a single change in this pass, so we do need to carry on. And we're going to do one final pass now. And we're going to discover there's no changes in this final pass, which means that the list is sorted. There we go. Looking through this for the marks, the first method mark comes from doing a bubble sort in a consistent direction. And for the end number 6 being in place, and the list beginning with the correct 4 numbers as well. So this is going to be M1. The first accuracy mark comes from the first, second, and third passes, all being correct. And the second accuracy mark comes from the fourth and fifth pass, also being correct. A fifth pass must be included. Okay, we're now asked to apply the first fit decreasing bin packing algorithm to pack the numbers into bins of size 85. So I'm going to write down my bins: bin 1, bin 2, bin 3. If I need any more bins, I will write those down as well. So does 33 fit into bin 1? Yes, it does. Does 28 fit into bin 1? Well, 33 plus 28 is 61, so yes, it does. Does 25 fit into bin 1? Well, I've currently got 61 in bin 1. If I had 25, that's going to give me 86, which is greater than 85. So 25 doesn't fit in bin 1, but it does fit into bin 2. Does 23 fit into bin 1? It does. That's going to have a total of 84. Does 21 fit into bin 1? No. Does 21 fit into bin 2? Yes, it does. Does 17 fit into bin 1? No, it doesn't. Does 17 fit into bin 2? Yes, it does. Does 14 fit into bin 1? No, it doesn't. Does 14 fit into bin 2? Yes, it does. Just for now, we've currently got 84 in bin 1. We currently have 20, 40, 50, 60, 6, 7. We've got 77 in bin 2. So these are just a little note for ourselves. Does 13 fit into bin 1? No. Does 13 fit into bin 2? No. Does 13 fit into bin 3? Yes, it does. Does 10 fit into bin 1? No. Bin 2? No. Bin 3? Yes. Does 9 fit into bin 1? No, it doesn't. Does it fit into bin 2? No, it doesn't. Does it fit into bin 3? Yes, it does. Last but not least, does 6 fit into bin 1? No, it doesn't. Does 6 fit into bin 2? No, it doesn't. Sorry, yes, it does. 6 plus 77 is 83. 6 does fit into bin 2. And we've now finished. So where do the marks come from in this question? Well, for part C, get a method mark for the correct first 5 values being placed correctly. So that's 33, 28, 23, 25, and 21. That's going to be our method mark. And then our accuracy mark for everything else being placed correctly. And that is the end of the question. So thank you for watching this video, and I'll see you next time. Goodbye.